All right, greetings everyone. So this is some homework help for section 5.6, the integration by parts section, and we got to find an antiderivative for arctangent of 4t with respect to t. To work this one out, if you just do a moment's thought, you can't do a regular substitution for this or some other technique. We're going to need integration by parts here. And I'm not going to do a whole lot of help, but I'll get you guys started. Now, it doesn't make any sense to put arctangent of 4t as dv because to find v, that's exactly what this problem is asking us to do. And so putting arctangent of 4t over here would, just be, redundant, I guess. We're going to just want dt over here. So v is going to be t, and then we'll put arctangent of 4t over here. Arctangent of 4t over here. And then when you take the derivative, you'll get 1 over 1 plus 4t quantity squared times 4. Let me make that a little smaller, times 4 dt over here. And then when you put it back together, when you have your integral part from t times this, just do another substitution because I'll just write that part down. You could do the rest of the integration by parts problem here. You can move the 4 outside, and then it's going to be t over 1 plus 16t squared dt. And then I would just let w be the 16t squared, and then the rest should work itself out fairly well for you. All right, for number 19, we need to find, it's actually a definite integral, but once you have the antiderivative, it's pretty straightforward for you to evaluate it. So I'm not going to help you with the definite integral and the limits of integration part of this. That'll be left for you to do. Just in terms of finding the antiderivative, I would first rewrite this to be this expression here. And then the integration by parts is fairly straightforward at that point, at least to an old guy like me. If you use Lipit, P comes before E, so the polynomials come before the exponentials. And so you're going to want something like this. This will be dy. This will be negative 1/2 e to the 2y. And then when you put it back together, it's the same process as you did over here for finishing the problem. So I'll leave that for you. For number 28, again, we've got limits of integration that I'll let you deal with later. Now, it does say to first make a substitution and then do integration by parts. And so the substitution, it might not be obvious here what's going on. I would first rewrite this in terms of the double angle formula for sine. So I got e to the cosine t, and the double angle formula for sine is 2 sine t cosine t, and then we got our dt here. And so my substitution, I'm going to let w equal cosine of t, since that's my inner function here, and I got its derivative here, and I still have that, but that's just the nature of this version of this problem. So negative sine t dt, negative dw is your sine t dt. And then from there, so we're going to, sorry, my dog distracted me for a split second there. So we had negative integral, and the negative for that there, and the dw out over there. The sine t dt is taken care of. The 2, move that out front. Didn't have anything to take care of the 2. Cosine is w, so I'll put w, and then I'll get e to the w here, like this. And then, hold on, sorry. All right, so going back to this here now for the integration by parts. Whoops, I'm already using u du and v dv. Well, we'll let u equal w, so this du becomes dw, and then we'll have e to the w dw over here, which means that this is just going to be e to the w, and the rest should work out fairly easily, and you should be good to go. If you need further help, come see me in office hours at some point. All right, go study.